Here we go. Starting with number 106. It's going to go calligraphy pen. Avi, stop talking. Thanks. 106 reads, what's the correct name for it? N3 minus. First off, N3 minus is the correct anion denotation, where it's -3 because it's going to add 3 electrons because it's in group 5. That's what nitrogen is. Because it has a negative charge, nitrogen or anything that's negative on the periodic table, it's going to lose some of the ending and add "ide," and this one is going to be nitride. So for number 106, your answer is C. Number 107. Aluminum is in group 3. It's a group 3 metal. Which ion does aluminum typically form? When you get your periodic table, I would right away do this: +1, +2, +3, plus or minus 4. I would do that all the way across so that you know what the charges are going to be. And when we look at group 3, which this is poorly drawn, but whatever. When you look at group 3, it has 3 electrons in the outer shell. And we said you could either add 5 or remove all 3. And you go with the lower number, we're going to get rid of 3. So we're going to get rid of 3. It's going to have a configuration now of the noble gas before it. When it was an atom on the periodic table, it was neutral. That meant protons equaled electrons. You have just gotten rid of 3 of the negative charges. So you have 3 positives that are not being canceled. +3. And you'll know it just because you wrote it on the periodic table, but that's the reasoning behind it. 108. Which of the following formulas represents an ionic compound? Not taking questions at this time. Ionic compound. To be ionic, it has to be a positive with a negative, and we list the positive first. So when you look at this on 108, CS2. What's the problem with CS2? Right. It's group 4. Plus or minus 4, don't know what to do. I told you that's covalent. BaI2. Ba is in the positive side, I is in the negative side. That's your ionic one. And it's a positive with a negative. So therefore the answer is B. That means the others don't make sense. 109. Which element when combined with fluorine would most likely form an ionic compound? Well, fluorine, we're looking for ionic, so it's a positive and a negative. Fluorine has a -1. We need some positive ion here. So, got to find a positive one. Lithium, yep, that's positive. Well, that's good because that's your answer. And let's see, B was carbon. Nope, that's group 4. C was phosphorus. And phosphorus is -3, so that's not going to work. We're looking for positive ones, and then chlorine's -1. So the only positive one is lithium. All right, naming acids. When you put the prefix hydro, once hydro goes down, what rule number am I looking at? 1. And when it's, whoa, that was tough. It's rule 1. And rule 1 deals with what ending? Ide. Therefore, the answer is A. We have, if it's hydro something ic acid, that means it came from something that ended in ide, like this. It could be that, nitride. It could be something like this, cyanide. But it ends in ide, therefore it's going to follow rule 1. But it has to have the hydrogen in front. That denotes it as being an acid. So it's this, which makes it an acid. Then you look at what that is. And that one ends in ide. See, 111. I'll tell you with you in a minute. Which of the following shows both the correct formula and the correct name of the acid? Let's see. Let's see, it's going to be C. Phosphoric acid. Phosphoric acid tells me it used to be phosphate. It's rule number 3. And phosphate is PO4 with a -3. When it's an acid, you put the H in front of it. It's going to be H3PO4. Correct answer is C. 112 reads, when an anion, well, anion is the second part. It's the negative part. And it says when an anion that is part of an acid. So I know it's going to be H+, that's the positive side, and I'm going to have some anion on this side, and it ends in ite. So looking at ITE, Not that anyone else will ask you that because I make up the rule numbers. This is rule number 2 when it ends in ite. So therefore, you're going to end with what in the acid? Right, O-U-S. So the answer is A. (113). What is the formula for sulfurous acid? Sulfurous tells me it was rule 2, which is ite. This used to be sulfite. You're going to have the polyatomic sheet. Sulfite is SO3 with a -2. It's an acid, which means in front of it, it's going to have H+. H with a +1. You have to crisscross the numbers. If you just have HSO3, it's wrong. You have to instead take your 2, bring it down here, so it's H2. Then the 1 goes with the SO3. You don't have to do anything because it's a 1. That is sulfurous acid. So therefore, 113, the answer is B. 114, hydrosulfuric acid. What's the formula? Well, so it's an acid, fine. Ignore that. It's got H+. It says sulfuric. So it says hydrosulfuric acid. That's rule 1. It came from IDE ending. It must come from sulfide. And what is sulfide? People mess this up a lot. Sulfide is not this, and it's not this, because with the O's, it gives you an ite, or in this case, it gives you an 8 ending. The ide comes from the periodic table. This must have been sulfur. So I have hydrogen with a +1. Sulfur on the periodic table is a -2. You cross the numbers, you get H2S. 114, the answer is D. 115, sulfur hexafluoride. First off, there's a prefix in that name. It's a covalent compound. Another word for covalent is molecular. If that's not the question it's really asking, it's saying just what's the formula. The prefixes tell you everything. The first one says sulfur. The first one, if it just says the name, there's only one of them. Hexafluoride, you have to know your prefixes. Hex is how many? 6. That's it, sulfur hexafluoride. So in that case, the answer is D. 116. Correct formula for barium chlorate. Barium, if you can't find it on the periodic table, I would tell you where it is because it's beyond the 18 you had to memorize. Barium is number 56. It's in group 2. Therefore, it is a +2 charge, and it is combining with chlorate. Chlorate, when you look it up on the polyatomic sheet I'm going to give to you, chlorate looks like this, ClO3 with a -1. When you cross them, you get Ba. Then the ClO3, all of that is found twice. That's your answer. Therefore, 116 should be C. 117. What are the coefficients that will balance the skeletal equation below? I'm just going to do this one. The other balancing ones I'm just going to skip. I don't think there are any real difficult ones I give to you. So this is aluminum chloride plus sodium hydroxide. And you're going to get AlOH3 plus NaCl. Though it doesn't ask you, my question is, what kind of reaction is that? You have to know your 6 reaction types. What is that one going to be? Derek? Double displacement. Acid base? No. Got the OH right here, but we don't have an H on the other one in front, so it's not an acid base, it's a double displacement. When you go to balance this thing out, let's see. You have, that's wrong, sorry. The 3 goes there. You have 3 OHs over here. On this side, you need 3 of these OHs. Pop a 3 in front. 3 NAs. I need 3 NAs. That gives me 3 CLs. Already have them. And 1 aluminum. That's it. So, nothing written means it's really a 1. It's 1, 3, 1, 3. Correct answer for 117 is A. 118. You have the following equation. It's Fe, I guess I'm doing this one. Iron plus chlorine. That's chlorine gas. What else do I know about chlorine gas? Besides it's deadly and everything. Thank you. It's diatomic. You have to know your diatomics. The diatomic, if you remember, periodic table deal. I don't even come close to doing this right. That's not bad. Oh, yeah. So we said diatomics were hydrogen plus start at 7, make a 7. Don't touch the noble gases. Chlorine falls in that realm, so by itself, chlorine is diatomic. And it's going to give you iron 3 chloride. Oh, iron 3 chloride. When you go to do this, these don't balance. 2 in front, that gives me 6 chlorines. A 3 in front, that gives me 6. 2 irons, 2 irons. 2, 3, 2 is what the answer should be. And it says, what's the coefficient in front of Cl2? It's a 3. The answer is C. 119. The equation. I'm not writing the whole thing out. The answer is simply B. When you go to do it out, you get a 2, 2, 3 for your numbers. And the question is saying, what's in front of the KClO3, which is potassium chlorate. And what's in front of that would be a 2. Number 120, in combustion. Combustion is one of those of the 6 that we had to know. One of the reactants is what? You have something plus always oxygen. Combustion. Okay, therefore it's going to be C for number 120. And usually what we do is we deal with, what did I call the things that were here? Who said it? Someone said it was even more than that. Yeah, I think it said hydrocarbons. Hydrocarbons. You need the you need hydrogen because you're going to end up with carbon dioxide plus water, and there's your hydrogens, and there's your carbons, and there's the oxygens that are going to go in those. So that's what combustion is going to look like. So you have your hydrocarbons. I know there's one of these on your final. Let's see. So that's why oxygen. Number 121. The type of reaction that takes place when one element reacts with a compound. So I have an element, a single element plus a compound, and you're going to get from it a new compound and an element by itself. What do we call that? Single displacement. Or replacement, one and the same. Depends on the book. Okay, 122. Reaction that takes place when one element. Nope, wrong one. Which of the following is correctly balanced for the incomplete combustion of heptane? Well, first of all, heptane is this. They're telling you it's combustion, so you have to be adding to it oxygen, and you're going to be getting from it carbon dioxide and water. So when I look at 122, I know combustion has this, and I know it's going to form that. So when I look at 122, all of a sudden A is gone because that's carbon monoxide, not carbon dioxide, so A is gone. B is gone because once again it's carbon monoxide. D is gone because it's not making the right stuff on the product side, so it's C. C is correct. It does have these components. 123. 123, the equation Mg plus 2HCl gives you MgCl2 plus H2. That's an example of single displacement. The answer is B. We're going to fly through these now. 124, the equation below, what kind of reaction? That's double displacement. You have a compound and a compound, and just switch things. 125, in that compound, what kind of reaction is it? It's going to be combustion. Same reasons as I said in 122. 126. Calculation of quantities in chemical equations is called stoichiometry. That's the name. And you do have several stoichiometries, especially near the end. Do know this. Your test is timed. Every question counts the same. So when you get a question like we just did in 126, the calculation of quantities in the chemical equation is called stoichiometry. That took you literally like 12 seconds to do. That counts the same as doing a calculation with stoichiometry, figuring out the limiting reagent, and figuring out the product. So what I'm going to tell you is do those last. Those take a lot more time. And they all count the same, so you might as well do the easier ones first. 127. If 1 egg and 1/3 cup of oil are needed, I don't feel like doing it. It's C. It's 3 times greater. In the reaction below, what is the ratio of moles of oxygen used to moles of carbon dioxide? So what you have to do for that one is, moles, we said, you can get the mole number by looking at whatever's in front of, for example, the CO. There's nothing in front, it's got 1 mole. Plus O2, it's got 1 mole. Yields 2 CO2, it's got 2 moles. They're saying what's the mole ratio of oxygen used to moles of CO2 produced. So they're telling you where to stop. They're telling you oxygen is the first one, so it's 1. To carbon dioxide, it's 2. It's 1 to 2. If you read it wrong and you get 2 to 1, it's wrong. So it's 1 to 2. Answer is C. 129. All right, I'm going to pause here.